Hey everyone, this is Rahul, Senior Data Scientist at Scry. Imagine you have built a system where smart devices like watches, meters, phones, or sensors are constantly sending data using a typical API-driven architecture. And the system stores all this data in a database. Initially, it works flawlessly, but as more and more devices come in, sending substantial amounts of data, effectively handling all this information becomes a big challenge. That's where event-driven architecture comes in. Let's first understand what is an event. An event is a change in state or an action that has taken place within the system. For example, a user has logged in or logged out. A password has changed, an email has been sent, or a data is updated. Basically, any kind of action in the system. In the scenario we discussed, an event would be when your system actually receives data from a device. Event-driven architecture uses something called publisher-subscriber model and has three main components: the producer, which publishes the events; the consumer, which subscribes to these events; and the broker, which facilitates the communication between the producer and the consumer. Now, don't get it confused with message-driven architecture. The idea is very similar, but there is a clear distinction between the both. In message-driven architecture, a message has a set of addressable recipients, while in event-driven architecture, the producer publishes the events and that is it. It doesn't care about how many subscribers are actually listening to these events. Let's revisit the previous scenario and discuss some of the advantages of event-driven architecture. As the number of devices increases, you can easily scale the system by adding more subscribers to handle the incoming events. This helps in efficiently managing the growing volume of data without causing bottlenecks. The publisher and the subscriber are completely decoupled from each other. The publisher doesn't need to know about its subscribers. Imagine if one of the subscribers goes down. The publisher doesn't need to stop publishing the data. As soon as the subscriber becomes online, it can pick up right from where it left off. Event-driven architecture enables you to adapt your system to the changing requirements. Imagine, apart from storing the data, you also want to check for anomalies and generate alerts. You can easily create separate pipelines by adding more subscribers for the task. Event-driven architecture does have some challenges as well. Let's be honest, managing numerous events, publishers, and subscribers across the system is not easy. It requires careful consideration of event flow and its processing. On top of that, there are additional infrastructure requirements that make the system more complex and a lot harder to debug. Event-driven architectures communicate asynchronously. When you need many events to follow a specific sequence, it can be difficult to make sure that these events are being created and processed in the right order. When you have multiple publishers or subscribers, the chances of duplicate events being created increases. If they are not managed properly, it can cause inconsistencies and redundant processing within the system. At Scry, we extensively use event-driven architectures for different use cases. We use streaming platforms to handle large volumes of data across various domains and applications. Apart from efficient but usual processing and storage of data, it also helps us manage separate pipelines to quickly react to critical events, send alerts, and make sense out of the data in real time. As an example, in one of our IoT systems, we utilize event-driven architecture for the communication between the gateway and the cloud. This helps the system to meet the requirements of ever-growing device count by allowing it to scale and seamlessly gather huge amounts of data. In conclusion, although event-driven architecture brings significant advantages, it's crucial to carefully consider both the benefits and possible challenges. If your application needs scalability and decoupling of components, the event-driven architecture could be a great fit. However, it is a must to always assess your specific requirements and then make the decisions. Thank you for watching. This is Rahul signing off.